Good evening, everyone. I
Evening,
hope
madam.
I am audible.
Good evening,
Yes,
ma'am. Audible.
audible, man. It's
Okay,
audible.
okay. So we'll start
Good evening,
with
madam.
today's session. So myself, the coordinator of this workshop, will be taking this session. So I'm Anupama, Assistant Professor of Department of Electronics and Communication, SJCE Mysore. Okay. In today's session, I'll be telling about nanomaterial applications required for the healthcare. So the contents of this session is introduction to nano, synthesis of nanomaterials, and nanotechnology for cancer diagnosis, cancer therapy, and also tissue engineering. So begin with, maybe you know what a nanoparticle by now, but still I'll start with this with a brief introduction of what a nanomaterial is. So a nanomaterial is any material which has one of its dimensions, either length, breadth, or height, in the nanometer range, that is from 1 to 100 nanometer. Nano means dwarf or small. Scientist named Norio Taniguchi in 1974 coined the term nanotechnology. So what is a nanometer? It is 1 billionth of a meter, that is 10 to the power of minus 9 meter. We'll just have a comparison of macro, micro, and nano scales. So here you can see this macro, micro, and nano objects. So what are macro objects? They're the one we can see with our naked eyes. So to see the micro objects, we need the microscope. And for nano objects, we still need a better microscope, that is a special microscope. So next is the classification of nanomaterials. Nanomaterials can be classified into 3 types based on its dimensions. It is called as one dimension nanometer if it has either one of the parameters, that is length, breadth, or height in nano. And it is a 2-dimensional material, nanomaterial, if it has both, that is length and breadth in nano scale. 3-dimensional nanomaterial is the one which has all the 3 dimensions, that is length, breadth, height in nanoscale. So example of 1-dimension nanoparticle or nanomaterial is thin films. So 2-dimension, it is nanotubes or nanofibers or nanowires. For 3-dimension, the example is nanoparticles and also nanoshells. Why do we need this nano when already macro or micro or milli is there? So what is the advantage of being or getting the material in small dimensions? So when the material reduces its size, there are many advantages of it. One main property or the unique property of this nano is it has high surface area to volume ratio. Okay, else it is nano objects are faster, lighter, and they're more energy efficient. We'll concentrate on the surface area to volume ratio because that is what the property is used in all the applications, most of the healthcare applications. So consider this cube here, one single cube of dimension 2 cross 2 cross 2. Okay, if we calculate the surface area of this, it is 24, and volume of this cube is 8. When we take the ratio of it, surface area to volume ratio, it is 3. Now assume that you have cut this single cube into 8 square cubes, small square cubes. Okay, now calculate the surface area of this. It is 48 and volume is 8. So now the surface area to volume ratio is 6. So here the surface area to volume ratio increases as the size decreases. So when this cube is still further cut into many small cubes, then again the surface area to volume ratio further increases. Okay, so what is the advantage of having this smaller cubes? So there will be more site for the reaction. Okay, so everywhere, all over the cube, there will be reaction. So a large surface area allows more active sites for chemical reactions, higher reaction rates due to more reactant contact with the material. So the nanomaterial properties is, as I discussed now, it is the high surface area and size dependent properties. That is, as the size reduces, the properties of the material changes. And the quantum effect, as the size changes, the material will be fluorescent, even that properties will change. So as the size changes, we'll see an example how the property of the material will change by taking an example of gold. See, the bulk gold, whatever gold we see, it is a inert material and it is shiny yellow in color. As the size reduces, that is, if the gold particle size is from 30 to 500 nanometer, it is metallic and the color changes from crimson to blue. And when the size of the gold nanoparticle is from 3 to 30 nanometer, the color is red and it is metallic. So the color keeps on changing as the size goes on reducing. At one point, it becomes colorless. So the bulk gold, it is the inert, it will be inert and it is a shiny yellow metal. So gold nanoparticles appear red and bulk gold does not exhibit this catalytic properties. That is, it is a inert material. Okay, here, nanotechnology is actually not new. See, the beautiful paintings which you're seeing here, they're not made of any color paints. They're actually made of gold and silver nanoparticles. And the color what we are seeing, it is due to the reflection or transmission of the light at different angles. So one more example of this is this Lycurgus cup. It is a Roman glass cup of 4th century. It works on this dichroic effect. See, if the light is reflected, it is the same glass, but see, you are able to see the 3 different colors. So when light is reflected, it appears green. When it is transmitted, it appears red. So this glass, it contains nanoscale particles of gold and silver. So when light interacts with these nanomaterials, surface plasma resonance occurs, scattering and absorbing specific wavelengths of light to create the dichroic effect. So nanotechnology is not new to India too, because this basmas or the Ayurvedic medicine, which we are using from ancient days, these are made of nanoparticles, which are used for the therapeutic use. These are the examples of different types of nanomaterials. We have nanoparticles, important types of nanomaterials, that is nanowires, nanotubes, graphene thin film, carbon nanotubes, and 3D polycrystal. This nanorobots, this is a new idea, and the scientists have developed this idea based on the bacteria moving from one part of the body to other using flagella. So instead of flagella here, the nanorobot, it has the tail here and a micro camera to take images to check whether it has reached the proper part or not. And also it has payload and a capacitor to give energy for this robot. So this robot, it swims through the blood using a pair of tail. So India has been making significant effects in nanotechnology in the fields like healthcare, agriculture, energy, water treatment, and defense. So research areas for nanotechnology have been developed in this IITs, IISc, and also in CSIR institutes. There are many diverse applications of these nanomaterials. This nanomaterials is used in agriculture too. See, because of these unique properties of the nanomaterials like high surface area, reactivity, and controlled release mechanisms, they enable innovative solutions for modern farming. For example, nanofertilizers, they enhance the delivery of nutrients to plants, reducing waste and increasing efficiency. Nanoclays, they improve soil structure and water retention. Silver nanoparticles exhibit these antimicrobial properties, protecting crops from bacterial and fungal infections. These nanomaterials are used in this environmental protection too. So because of the same unique properties, applications like pollutant remediation to renewable energy systems are possible. For example, this water purification using nanostructured filters. So nanoporous membranes and carbon nanotubes, they remove the contaminants, including heavy metals, bacteria, and organic pollutants. One more example is this environmental sensors or the nanosensors. They detected pollutants such as heavy metals and greenhouse gases with high sensitivity. The other application of nanomaterial is the consumer goods. So because of the properties like this reactivity, mechanical strength, they enable the creation of products that are more efficient, durable, and sustainable. For example, you have this nano silver. They provide antimicrobial properties to clothing and footwear. They reduce odors by preventing the bacterial growth. And zinc oxide nanoparticles, they're widely used in sunscreens for effective UV protection without leaving a white residue. And nanoclays are also used in this food packaging to improve barrier properties, keeping food fresher for longer time. And in case of energy sources, they'll give an efficient energy generation, storage, and conversion. Example, we have the silver nanoparticles again, which enhance the performance of silicon-based solar panels by improving light absorption and reducing the material use. And lithium-ion batteries, graphene and silicon nanoparticles increase the capacity and charging speed of electrodes. And the application in biomedical research, this nanoscale dimensions enable interaction with biological system at the molecular and cellular levels. These gold nanoparticles are used in imaging, drug delivery, and cancer therapy. Silver nanoparticles, they're applied in wound healing and infection control. And polymeric nanoparticles, they enable controlled drug release. And smart cities are also possible using this nanotechnology. This nanosilica, it enhances the strength, durability, and resistance to cracking in concrete. Carbon nanotubes, they improve the tensile strength and toughness of the concrete. And graphene, they add the exceptional strength and flexibility to composite materials. And in case of electronics and machines, these nanoparticles, they have high electrical conductivity, mechanical strength, thermal stability, and so these properties make them invaluable for modern electronics and machines. The graphene, they have exceptional electrical conductivity and mechanical strength. Carbon nanotubes, they can carry high current carrying capacity and thermal conductivity. So in the this composite materials, if we use, they have the high strength to weight ratio and enhanced strength and wear resistance for mechanical components. So the applications of this nanomaterials is also in the healthcare. They are the ideal candidates for wide range of biomedical applications. Common types of nanomaterials used in healthcare are this nanoparticles, carbon-based materials like gold, silver, silica, carbon nanotubes, and graphene are used. So applications, okay, usually in healthcare, these nanoparticles or materials are used to treat cancer, Parkinson's, and Alzheimer's disease. The applications of nanomaterial in healthcare are this drug delivery system. This drug delivery system is delivering the drug to the specific part of the body. So targeted drug delivery is possible, controlled release of the drug is possible. So nanomaterials can be engineered to release drugs in control manner over time. So this is benefited for devices that require consistent drug levels such as cancer or other chronic diseases. Next application in the healthcare is this cancer diagnostics and treatment. So early detection of cancer is possible. Usually cancer is not cured or the patient dies of cancer because it is not diagnosed earlier. So at later stages, it is diagnosed. So early detection is possible using this nanotechnology. So in biosensors, next application is this biosensors and diagnostics. So this includes the transducer plus the biological recognition element. So multiplex diagnostics is possible. So that is the nanomaterials, they allow for detection of multiple biomarkers. Next, wound healing. These materials can be used to create advanced dressings. That is, for example, nanogels, they can deliver drugs directly to the wound site, reducing the risk of infection and promoting healing. Next application is this implants and prosthetics. Implants is placing the plate or screws in the body. And prosthetics, for example is the artificial limb. So nanomaterials can be used to enhance the properties of implants and prosthetics too, such as making them more biocompatible, durable, and resistant to infection. Coatings made of nanomaterials are applied to implants such as joint replacements to reduce wear and tear, enhancing the cell attachment. Next is this regenerative medicine. So this regenerative medicine, it is a branch of medicine focused on repairing or replacing the damaged tissues. There you have methods like stem cell therapy and tissue engineering. There the damaged or repaired tissues are replaced. Next is this antibacterial or the antiviral applications. So these nanomaterials can also be used to develop coatings or materials that inhibit or they stop the viral replication. In imaging and therapy, that is also known as theranostics, that is instead of doing the diagnosis once and the treatment once, they both can be done together. So theranostics is imaging and therapy done together. So gene therapy is nanomaterials can be used to deliver the genes to the specific cells. And there are also smart bandages and wearables using this nanotechnology. So here nanomaterials are used to develop wearable devices that monitors patients' health in real time. So because of these uses like improved drug delivery, diagnostic accuracy, tissue regeneration, and infection control positions, this nanomaterials, they play a key role or focus for future medical innovations. Okay. Tubes and nanowires, the branch structures, they are the artificial polymer. Nanocomposites is the combination of the matrix and the filler. That is, two types of materials are added in this to enhance the efficiency of the composite material. So here, see the structure of the dendrimer. These dendrimers are highly branched tree-like structure. Okay, so the center part is the core and remaining is the branches. So this synthesis, mainly they can be this synthesis of dendrimers. There are three main methods. They are the divergent synthesis, convergent synthesis, and mixed mode synthesis. So in this divergent synthesis, that is, uh, that is the bulk materials here are broken down into smaller particles. So what we can imagine is from a rock, if a statue has to be made, then we have to cut the unwanted parts. So like that, from the large scale, it is broken into smaller particles. The advantages of this method is scalability, versatility, that is the adaptability with wide variety of core structures, and surface functional groups can be tailored at each step. Challenges in this method is in case if there are any structural defects, then it lead to defective dendrimers. And purification, then removing the incomplete or partially reacted dendrimers is also difficult. And large generations, it require increasingly complex synthetic steps. And the applications of this dendrimers is they are used for drug delivery, gene therapy, imaging, and antimicrobial agents. This convergent synthesis is assembling the atoms or molecules through chemical reactions or physical interactions. So examples of this method, it includes self-assembly and solution gel method. Here the advantages of this method is reduced defect. So then that divergent method, here the defect will be reduced when the dendrimer is synthesized in this manner. Next, ease of purification and precise control, that is control, we can have the control over the size. So challenges is limited generations, complex synthesis, and scalability, difficult to scale up for industrial applications. Applications, this is for medical applications, it is the same. Whatever way we synthesize, the application is the same. So in mixed mode synthesis, here it combines the method of both divergent and convergent method. So here the advantages of both the methods are added and in this mixed mode synthesis. Next is the synthesis of nanoparticles using laser ablation method. So this laser ablation method, it is a technique used for synthesizing the nanomaterials. So in this method, what is done actually is a high powered laser is directed at a solid target particle. So this causes the surface to vaporize into plasma, and this vapor condenses to form nanoparticles. So here in the setup, it includes a laser source, a target material, a chamber, and the nanoparticle. The target material here, for example, it might be graphite or any metal. So it is placed in the chamber and the beam of laser is focused on it. So due to the energy of the laser, the material, it heats and vaporizes. So the plasma is formed, and next this is cooled using a coolant to condense the nanoparticles. So advantages of this laser ablation method is high purity, adaptability to wide range of materials, and size can be controlled. Next is the synthesis of carbon nanotubes using the chemical vapor deposition. So in this technique, the nanomaterials such as thin films, nanowires, and nanotubes can be synthesized. The process involves a chemical reaction here, then a vapor phase precursors to deposit a material onto a substrate. Here, initially what happens, the gaseous precursors containing the material, for example, methane, it is introduced into the chamber. So the substrate is heated. Okay, and this is heated, and this heat, it promotes the decomposition of the precursors. And due to the chemical reaction, whatever the nanoparticles is got, it is collected on the substrate. And here you have advantages like cost effectiveness, versatility, and the size control and scalability. And this is electrospinning method used for synthesizing the nanofibers. So in this electrospinning method, this is the apparatus used for the electrospinning method. Applied voltage and electric field will be around 34.4 to 36.5 kilovolts and from 1.6 to 1.7 kilovolt per centimeter. The drum speed is 200 RPM, flow rate is 0.4 ml per hour, and distance between the needle and the collected drum is 21.5 centimeter. Here there are two electrodes. At one electrode, the polymer solution is placed. Okay, this is the polymer solution. And due to this voltage applied, the nanofibers are collected at the other electrode. Okay, here at the collector, there is a rotating drum. On this, the nanofibers are collected. So the advantage of this electrospinning method is it produces continuous fibers, and the whatever fiber is synthesized, it will be uniform in size. So next we'll see the materials used for the cancer diagnosis. So before going to this materials used for the cancer diagnosis, can anybody tell me what is the difference between a cancer and a tumor?
In cancer, there is growth of unwanted cells, and in which there is formation of some nerves. We can say some not nerves, but there is blood circulation in the tumors also. In normal tumor, there is no blood circulation. But in cancerous, there is blood circulation, and it is harmful to human body as compared to normal tumor.
Okay, to be more precise, see, you actually in our body, the cells will be growing. There'll be every day cells will be dying and cells will be growing. When there is abnormal growth of cells, then it will be a problem. So when the cell grows, what happens sometimes they grow in the same place. Sometimes few of the cells they escape and they enter into other parts of the body. Okay, if this abnormal growth of the cell stays in the same place, then it is a tumor. Okay, tumor is a abnormal growth of cells. There are two types in it, benign and malignant. So in benign, the cells they do not spread to other parts of the body. Example of this is fibroid. Okay, it is a tumor. In case if that cell escapes and it moves to other part of the body, then it is a cancerous cell. And those cancerous cells are these malignant cells. So cancer, it's actually a subset of tumor. Not all tumors are cancerous, but all cancers involve malignant cells. So if the abnormal growth of the cell remains, does not spread to other part of the body, it is a tumor. If it spreads to other parts of the body, it is a cancer. So example of cancer is leukemia and lymphoma. In leukemia, what happens is there will be abnormal or excessive production of leukocytes. In lymphoma, there will be abnormal production of lymphocytes. So what is the reason for cancer? Oh, maybe the cancer is formed due to this genetic factors, that is due to mutation, translocation, and amplification. And also environmental factors also affect the development of cancerous cells like UV, chemicals, and viral infection. So those who usually work in the chemical industry, they have chances of getting cancer. And when the proto-oncogenes get converted to oncogenes, then there is possible, then definitely there will be cancer. So what is this proto-oncogenes means? They are the normal genes. Okay, they are the normal cells. Proto-oncogenes, they are the normal cells. When they get converted into oncogenes, they become cancerous. So when this proto-oncogenes, that is the healthy cell, when it get converted to oncogenes, it is a cancer cell. Next is when there is alteration in this tumor suppressor genes, TSG. That is, this tumor suppressor genes, it is the immune and it will be that it will suppress the oncogenes. Okay, so when there is alteration, that is when this tumor suppressor gene is not able to suppress the oncogene, then there will be chances of getting cancer. So here, see, there should be a balance between this oncogene and tumor suppressor gene. If it is balanced, then there will be normal cell. In case if there is imbalance, that is if oncogene's production is more and this tumor suppressor gene, that is the TSG, it is not able to suppress the oncogene, then it will get converted into cancer cell. So one interesting point is about this cancer. Every day, at least once a day, our immune system, it destroys a cancer cell that would become a cancer if it lived. Every day, these cancerous cells are produced, but if our immunity is strong, then it will be able to destroy the cancer cell. Otherwise, it remains and the cancer cells, it goes on replicating if the immune system is weak. Okay, this video. Okay, this is a animated video. Here it shows how the normal cells, that is the tumor suppressor cell, it kills the cancerous cells. So yellow cell which we can see here is the healthy cell, and the pink cell is the cancerous cell. Okay, so okay, next is see the if the cancer is diagnosed earlier, then it can be cured. Due to the late diagnosis of the cancer, the patient is not able to recover from it. One of the important nanoparticles or the nanomaterial is the quantum dots. These quantum dots, they are highly fluorescent and they are of small size. And as the size varies, since they are fluorescent, they emit different colors. So this property, it can be used for the cancer cell or the cancer diagnosis. So how it can be used is, so this cannot be used directly because they are toxic. So to make it biocompatible, they are covered with the inorganic layer and then with the organic layer. So in the organic layer, the antibodies can be attached and injected into the human body so that they can go and settle on the or get connected to the cancerous cell. So here, see, here in the first case, the ultraviolet light is off, so the quantum dots are there. So next is when the UV light is on, the quantum dots emit light because of their fluorescent property. So this property can be used to detect the cancerous cells. So here see the quantum dots when they are injected into the body with the antibodies, they get settled on this or get attached to this cancerous cells. So this green part is the cancerous cells and the remaining pink color is the healthy cells. So when the UV light ray is emitted on it, only the cancerous cells, they will be seen. So this is actually this, since it is toxic, still research is going on this quantum dots to be used in the human body. But till now, this is used, experimented with the cancer in rats. So the quantum dots are injected into the rat's body and see, we can see with the rat which has cancer. So here we can see the UV light on the because of this quantum dots, the fluorescent light of this quantum dots. So next alternative to this, since this quantum dot is a high metal and little toxic, this carbon dots are alternative to it. Their size is typically less than 10 nanometer and they are biocompatible and low toxic and ease of functionalization. A comparison of carbon dots versus quantum dots. Carbon dots are made of carbon-based materials, and quantum dots, they are the semiconductor materials. Size is almost the same, and carbon dots are less toxic, whereas the quantum dots are highly toxic. And these are biodegradable, and quantum dots are non-biodegradable. Okay, so these are the methods for cancer diagnosis. After the diagnosis, the nanotechnology used for treating the cancer. So here we'll have the background of cancer treatment, drawbacks of the traditional methods, advantage of nanotechnology and what is passive and active targeting, and the various nanomaterials used for cancer therapy. According to this American Cancer Society, the two main types of cancer are the lung cancer in male and breast cancer usually in females. In 19th century, there was the birth of oncology, and current cancer treatments are the surgery, radiation, hormone therapy, and targeted therapy. Here is the drawbacks of the chemotherapy. There are many side effects in this chemotherapy, and with the cancerous cells, the normal cells, healthy cells are also destroyed. See, and apart from that, there will be the patient will feel fatigue, that is extreme tiredness, nausea and vomiting, and hair loss due to damage of hair follicles, and infection, that is damage to bone marrow, and it weakens the immune system. Advantages of this nanotechnology is it helps increasing the solubility and they are biocompatible. It increasing the solubility because of its size. See, for example, in case if we want to dissolve a tablet in water, it takes some time. Okay, if the tablet is crushed and then dissolved, then it will be easily soluble. Okay. Like that, because of its size, the solubility also increases. And nanoparticles with diameter less than 200 nanometer are not screened out from the circulation by liver and spleen. That is because of their small size, they are able to move to any part of the body. They are able to escape in the blood vessels. They are not filtered by the liver. Then multiple drug delivery is possible to the tumor site compared to the traditional method using this nanocarriers. Here, see the comparison between the traditional treatment and the nanotechnology treatment. In case of traditional treatment, the drug, it destroys the healthy cells and also the cancerous cells. Whereas in case of nanotechnology, only the cancerous cells are destroyed. Okay, this is one more method of target drug delivery, that is the passive and active targeting. This passive difference between this passive and active targeting is, see, when the cell becomes cancer, actually there will be leaky blood vessels. Okay, through that leaky blood vessels, the nanoparticle goes and attaches into the cancerous cells. In case of active targeting, what happens? The particle, it is attached, nanoparticle is attached with the antibodies before, and then they are allowed or injected into the body, and they go and bind specifically to the cancer cell. Okay, and this improvement in this drug delivery is this stealth technology. So what happens is, whatever foreign material we inject into our body, our immune system refuses it initially. Okay, they refuses it, so it might not be useful. See here in this first diagram, we can see that if the nanoparticles are stuck in this immune system. So to avoid that, the nanoparticles are coated with PEG, that is polyethylene glycol, and then they can escape through the immune system. They become invisible to the immune system, and they are able to escape. So this PEG is water soluble and they are biocompatible. Advantages of this PEG is, when the PEG is coated to the nanoparticle, its size increases little. So this reduces the kidney filtration. Increase in solubility due to PEG, and also decreased accessibility for enzymes and antibodies. So this is one method about the cell technology. And one more nanoparticle used in this drug delivery is this nanoshells. Here, these nanoshells, they have the metallic outer layer and a silica core. So selectively, they are attracted to the cancer cells, either through the phenomena known as EPR. EPR, as I told, that there will be leaky blood vessels due to that, or we can add specific antibodies which can go and specifically bind to the cancer cells. That is either through the active targeting or through the passive targeting. So this EPR is this enhanced permeability and retention. That is, leaky blood vessels will exist wherever the cancer cells are. Due to the cancerous cells, there will be leaky blood vessels. So this nanoshells, they will get attached only to the cancerous cells. Okay, and when the actually, as the temperature increases, it will be destroyed. That is, when the UV light is left on it or made incident on it due to heat, the cancerous, there will be dead cancer cells and the healthy cells will be as it is. So one more method is this, using this albumin nanoparticles for this drug encapsulation. So the drug is encapsulated within, or it is absorbed into this albumin nanoparticles using different methods like dissolvation, nanoprecipitation, or the spray dyeing. So to improve the targeting, the surface of the albumin nanoparticles, they are modified with the ligands, antibodies, so that they can specifically bind to the cancer cell receptors. And dendrimers, which are the artificial polymers, they are also used for this drug delivery. Here, the advantage of this is, the drug can be placed either in the core or in the gap between these branches or at the edges. So multiple drugs can be transferred using these dendrimers. Using nanofibers also, the drug delivery is possible. See, in this nanofiber, the drug can be placed either on the outside the core or inside the core. Here, two types of drugs can be injected. So this is theranostics, as I said before, that is, instead of doing the diagnosis once and therapy later, they can be done together. So here, how they can be done together is, using this nanoparticle, we can add an imaging agent to it and the drug at the other side, and they can be transmitted. one more example of this targeted drug delivery. This is using this magnetic nanoparticles. So this magnetic nanoparticles, assume this is a limb, so it is injected here. So in case if we want the drug to stay at the same place, a magnet can be placed outside the body so that the nanoparticles can stay at that place for longer time. Since they are magnetic nanoparticles, they are attracted towards this magnet. Okay, next is the usage of nanotechnology in tissue engineering. Tissue engineering, as I said, it is the replacement of damaged or repaired tissues. So here we have the replacement of damaged or repaired tissues. Here, what the new thing is, instead of taking the tissue from some other person, from the patient's body itself, the tissue is taken, grown outside in the lab, and then it is placed back in the patient's body again. Then there will be no immune system, so that if some part is added to some other person, there might be rejection of the foreign particle. That is avoided here. So why do we need this tissue engineering is, see, thousands of patients, they need organ transplant, but they die before they receive a suitable organ. So traditional treatments for tissue and organ damage, they actually often cannot, they restore the functionality. So this is the procedure of this tissue engineering. See, the cell is taken from the patient and it is lab grown, and the scaffold is used to place these cells. Scaffold is nothing but like a support to hold the cells. Okay, and this scaffold is made of nanomaterial, and that cell, including scaffold, including the cell, it is placed back into the human body after adding all the whatever hormone properties are there. After adding everything, it is placed back into the human body. So three tools of tissue engineering are the cells, that is the living part of the tissue, and scaffold, it provides structural support, and cell signaling that usually includes the hormone growth factors. So engineered tissue, it needs cells, the scaffold, and the growth factor. So scaffolds, these are the various types of scaffolds used: fibrous scaffold, porous scaffold, and hydrogel. Tissue engineering is actually successful in skin, bone, and cartilage. Actually, research is still needed for this liver, heart, and if this liver, heart, lung, and kidney has to be placed into the human body. Okay, because there are multiple cells in this case, and they have the multiple functions. It is more complex than the replacing this skin, bone, and cartilage. So this is an example of skin tissue engineering. See here, you can see the damaged skin in this part. Okay, damaged skin is there. And if it is not replaced, what happens? Scar might be developed. So what has to be done is, the cell has to be grown outside, and it has to be kept in the scaffold and then placed back into the hand again, so that there will be no scars. So why nanotechnology in this tissue engineering? Okay, because it allows precise control at the molecular and nanoscale level, and effective delivery of growth factors, drugs, or genes is possible, which is not possible in the convention methods. And scaffold, they must balance the mechanical strength and flexibility to match the properties of the target tissue. So this nanofibers, here I'm telling you about nanofibers because the advantages of this nanofibers in this tissue engineering, which is used as a scaffold, is this single cell, they can bind to thousands of nanofibers. So a single cell can bind to thousands of nanofibers. So the single cell, it contacts to many fibers. Here, the synthesis of this nanofibers, electrospinning, already I have told. Self-assembly. Self-assembly is that is placing from small to big, and phase separation. Phase separation here, what actually is done for the synthesis of this nanofibers is, it involves dissolving a polymer in a solvent at high temperature, followed by a liquid or solid liquid phase separation induced by lowering the solution temperature. Okay, so these are the few of the applications which are used in the cancer diagnosis, cancer therapy, and in tissue engineering. So apart from all these advantages, care also has to be taken. There are few limitations in this nanotechnology. That is, see in the sunscreen, these nanoparticles are used. That is, zinc oxide is the nanoparticle used. So now it is fine, but far that is at later stages, what happens, that is research has to be done through it still. So in the nanoparticles used for this drug carriers, they might harm the cells. And immune response in the nanomaterials, they might provoke unwanted immune reaction. And when the products degrade, they may be toxic. Okay, and long-term effect, it has to be done. But apart from this, there are many applications in this nanotechnology, and few of the limitations have to be addressed. Okay, a few more videos are there on this. I'll just try to play it of this cancer treatment. Okay, and before that, I like to tell you few important things. Okay, that video will be played later. So here totally for this workshop, you all have 13 sessions. Okay, I hope you are aware of it. So in that 13 sessions, already 10 sessions are over. Okay, 9 sessions are over. One more session, if the 7:30 session completes, then 10 sessions will be over by today. And tomorrow there are 3 sessions, and tomorrow's timings is from 2 o'clock. I hope you all know that. Tomorrow it is the first session is from 2 to 3:30, then 3:30 to 5, then 5 to 6:30. Okay, from 6:30 to 7:30, test will be conducted. You will be able to take up the test in the ATAL website itself. If you have 80% attendance. By tomorrow morning, attendance will be updated. Most of your attendance are already updated. Okay, if those whose attendance is not reflecting, I'll update it by tomorrow. Just check you will be able to take the test if you have 80% attendance. And in the test, you have to score 70% marks. So from 6:30 to 7:30, you will be taking the test and also the feedback. As soon as you take the test, you have to give the feedback. And once you have done with the feedback, then only you will be able to download the certificate. Any doubts on this? Doubts regarding the test?
Excuse
Hello,
me,
no
ma'am.
doubt?
Ma'am,
Yeah.
our test will appear where in the ATAL website?
That wherever you have got registered, if you click on it,
Okay. On the
their
same
test
FDP
option will be
program
there.
where we registered.
Pardon me?
Ma'am, on the same FDP program where we registered?
Yes.
Okay.
If you get the 80% attendance, then automatically the test questions will be visible for you.
Okay. Thank you so much, ma'am.
Okay. Any doubts regarding this, taking the test?
Hello.
Yeah. The test will be MCQ, 4 choices you will be having. Yeah, tell me.
No, for the test, I think in last FDP I have given on Google form.
Okay, you can take it if you take it in the ATAL portal, the marks will be automatically available there. So in the
Is
Google
now
form, we have to enter the
there are
marks individually.
new guidelines from ATAL FDP.
No. Both ways can be given. Both ways can be given. We can do it in Google form and later enter the test marks, or the test can be given in the ATAL portal itself, and the system it will automatically calculate the marks.
Okay.
And it will be available for
So
you.
which is better for participants?
ATAL portal. I'll be giving the test in the portal itself.
Okay.
Okay, tomorrow it's 6:30 to 7:30. And in the next session, please do everybody listen properly, because Dr. Srinivas sir, he'll be just giving the sample or the sample questions on what might, what the questions might appear tomorrow. He'll be discussing about it. So please do attend the 7:30 session. Few sample questions like what you might get tomorrow. So do attend it.
Today that will be discussed, huh?
Yes, 7:30. He'll be showing few videos on this biomedical applications and telling on the research funding projects and also on this test. So a mock test will be conducted for you.
Okay.
Okay, so any doubts regarding this test? So maybe few of your attendance is already updated in the portal, just check. If it is not, by tomorrow afternoon, we'll do it. And feedback also you have to give in the portal itself. So if you give the feedback itself, you will be able to download your certificate. Okay, then. Next session will start from 7:30. You can take a break till then.
Good evening to all. So today, mainly I am focusing on I will show you what are the list of funding agency from Government of India, how to get the funding, and so what are the resources. Those things I want to share you. And second thing, very important videos on MEMS fabrication. MEMS fabrication. So this video you don't get from internet and all. So it is very informative regarding fabrication, how to do the real-time fabrication, hands-on training, and fab facilities from Indian Institute of Science. Next, MEMS applications video I want to share you. With this second session is just we are going to conduct the test. A coordinator will share the questions and all. So now I want to show you what are the funding agencies. 1 minute. So I think it's visible. Yes, it's visible.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, so these are the various funding agencies. So one thing I can tell you, my personal experience. So if the proposal is good, really it is good, and if the proposal having novelty, and if the proposal is societal applications, so without any recommendations or anything, you will get the funding. So this is my personal experience, because I have got very good funding from Government of India, from especially from DST. So in DST there is a separate wing for nanotechnology. So for nanotechnology there is a separate wing, and throughout the year so few proposals are there, few schemes are there. So those schemes having no deadline and all. So throughout the year you can submit the proposals. Hello. Next, and next, please mute the mic, please. Next, and so few schemes were few schemes yearly twice they will call for the notification. Anyway, you go with the good proposals, but the thing is, the proposal must be having societal application. So this is very important. So if it is societal application, then chances are there to get the funding and all. So here we have a list of the funding agencies. So I don't want to read all these funding agencies. Just I will show you, but I will share this PDF file. Whenever if you are having a time, sufficient time, please go through these websites. You will get the information about like what kind of funding they are going to provide, and you can have a lot of information about getting the funding. So especially coming to all the funding agencies, just you focus on three agencies mainly. That is Department of Science and Technology. So there is a lot of scope on nanomaterials to get the funding, and you go with novelty of the research proposal. So you will get, and one more in DST, one more wing is there, that is SCRB. So SCRB normally every year they used to call for the proposals, like major projects and as well as the minor projects. Even you can conduct the workshops also. They used to provide 1 lakh grant for to conduct the workshop on nanotechnology or nanomaterials or any related to biomedical applications also. So around we have 48 agencies to get the funding and all. So here Science and Engineering Research Board, SERB. So I think every 3 months, 4 months, they used to call for the proposals. And some of the schemes having throughout the year you can submit. Better you first you sign up and you create the account, and whenever if they will call for proposal, you can upload the proposal. It is good. And even sometimes UGC also will call for the proposals on nanotechnology. So you go through this all these websites. You will get lot of information about the funding and all. Even Ministry of Communication and Information Technology, so they used to call a very good they used to provide very good funding on societal application technology, related to societal application technology. So these are the different types of funding agencies, and with link also, their website link. So free time, better you go through all these links. Why I am saying funding is important means, without funding you can it is very difficult to carry out the research work, because dealing with nanomaterials and characterization, fabrication, it is too much cost. So if you got funding and all, you can complete the research work within the time, and so some funding support will be there. And it is less time only you can complete the work, and getting the funding and complete the research work is very good. So even you can go for real time patents and all, and you can publish SCI journals, because with your funding you can purchase the required instruments, and you can attend the conferences, and you can conduct the workshops. So you can do characterization, different types of characterization. So means you can find out novelty of the work if you are having funding from the agencies. So after this session, I will share you all these. Please look into these agencies website. You will get the clear information for the procedure to apply the funding and all. So this is I would like to discuss about these funding agencies. And with this, afterwards, there is a very important information, Government of India established Fab Lab at ISC Bangalore. So once if you visit ISC Bangalore Fabrication Lab, so it is very good, because we have very good characterization facilities. So if you're having if you want to do any kind of characterization, the facilities are available. So I have worked at ISC Bangalore when I was doing my research work. 20 days I stayed in ISC Bangalore, and have done characterization and even fabrication, hands-on training. I am INUP user, and the same facilities at IIT Bombay also. So if you can write the proposal to the ISC. Once the proposal is going through experts, if it is selected, they will give permission to carry out your research work. So all these information, it is available in Indian Institute of Science. And even characterization. See, for example, before going to start the research work, they used to conduct one workshop. So if you selected in that workshop, well, you will be treated as INUP user. So there are many benefits if you become INUP user. because if you do the characterization, they used to take very less amount, very normal charge they will take for the characterization. Even for fabrication also they will give some facilities. So better you look into that. You can carry out the research work in a systematic way, and very shortly you will get the your required work. So this is the information I want to share you. And one more thing, today 3 important videos. One is related to MEMS fabrication. So MEMS fabrication having wide range of applications. So nowadays in almost all applications we are using MEMS. So even to work to get the very good functionalities, different types of functionalities, the material. So what kind of material you are using for the fabrication of MEMS is very, very important. And here in the video, the fabrication procedure is very clear. So you will get very good understanding about the fabrication of MEMS, how we are going to fabricate the MEMS with different design metrics. And the characterization part also you will see. It is not only it is 5 minutes or less than 5 minutes video. So this video you don't get anywhere in the YouTube and all. So this is a very, very informative video. And MEMS applications, also one more video is there, MEMS applications, where we can use the MEMS applications and how the MEMS is going to work, because it is a electromechanical system having both signals like mechanical and as well as electrical signals, and how it is going to have different types of applications and all. So those things it will be clear. So with this, I would like to share the MEMS application videos. Please have a video.
Look closely and you will see them. Tiny machines, nearly invisible to the human eye. These micro machines make automobiles safer. Insulin. Look closely and you will see them. Tiny machines, nearly invisible to the human eye. These micro machines make automobiles safer, insulin pumps for diabetics more accurate, and hearing aids more efficient. MEMS, or micro-electromechanical systems, describes both a category of devices and the technique for manufacturing them. These tiny devices have elements ranging in size from 1 to 100 microns, about the thickness of a human hair. MEMS devices are generally divided into 2 categories: sensors and actuators. Sensor devices gather information from their surroundings, and actuators execute given commands or act generally through highly controlled movements. MEMS are made using the basic fabrication techniques and materials of microelectronics. Thin layers of materials are deposited onto a base and then are selectively etched away, leaving a microscopic three-dimensional structure. In this way, MEMS processes construct mechanical as well as electrical components. The electrical elements on the chip process data, while the mechanical elements act in response to that data. Hence, a complete system on a chip. Integrated circuitry provides the thinking part of the system, while the MEMS component complements this intelligence with active perception and control functions. Known as MST or Microsystems Technology in Europe and Asia, the potential for MEMS technology is endless. MEMS devices are already used in an extensive range of products. They can be produced in large quantities with proven fabrication techniques. For example, crash sensors for airbag safety systems are actually MEMS devices that measure the force of an automobile crash and deploy an airbag if the force is great enough. Also, with the help of MEMS printheads, inkjet printers have developed from crude, slow, black and white devices to fast, flexible photographic quality imagers. And thanks to MEMS digital micro mirrors that control light, video projectors in offices around the world are now able to produce razor-sharp, bright, colorful images. MEMS technology has become so widespread since its beginnings in the 1980s that it is estimated that there are now between 15 to 20 MEMS devices for every person living in North America. There are two common examples of MEMS improving existing technology: the automotive crash sensor and the digital micro mirror device. A key element of modern automotive airbag systems is the MEMS crash sensor, known as a MEMS accelerometer. These sensors are more effective than earlier systems, meeting more stringent safety standards. The core of the MEMS accelerometer is a central mass that moves in response to a vehicle's acceleration. This inertial mass is mounted on a hinge or spring that limits its movement and returns it to a central position when at rest. Sensitive electrical sensors in the chip read the mass's movement and relay this data to a connected microprocessor. The microprocessor monitors the state of the accelerometer at rest and in motion. In a collision, there is a sudden change in acceleration. When this change reaches an unsafe level, the airbags are deployed. The entire process takes only a fraction of a second and has saved millions of lives. MEMS technology allows crash sensors to be built from one or two simple chips. Earlier systems needed many electrical and mechanical components located throughout an automobile for measuring the same data. Reducing the number of components increases the accuracy and lowers the cost of these systems. The MEMS micromirror device, or DMD chip, is used in modern video projectors, home theater systems, and televisions. This chip uses microscopic moving mirrors to improve the image quality and overall reliability of these products. The micromirror device is, in its simplest form, a light switch made of millions of hinge-mounted mirrors. Each mirror measures about 1/5 the width of a human hair and corresponds to one dot or pixel in a projected image. Mirrors are mounted on tiny hinges that enable them to tilt either toward the light source to reflect light or away from it to block the light. This creates a light or dark point on the projection surface. The length of time the mirror faces the light determines the brightness of each dot. In color systems, projectors can create over 16 million shades of color. These systems are producing such high-quality images that they are now being installed in movie theaters, replacing film projectors. MEMS technology will continue to quietly improve life as we move into the future. We may not be able to see the devices, but we will see its applications as they continue to affect our lives. Because MEMS is a flexible technology, it has the unique ability to improve current products, delivering new levels of performance and efficiency to both mass market and highly specialized applications. In the computer market, MEMS is revolutionizing mass data storage by miniaturizing components for disk drives, servers, and peripherals, meeting the increasing needs for low-cost, high-capacity digital storage. In the consumer electronics market, acoustic MEMS chips are changing the way sound reaches our ears through cell phones, personal stereos, and hearing aids, providing less distortion and higher quality and clarity of sound. MEMS technology is meeting its potential for greater commercial use in several fields of technology. In addition, MEMS size and integration allow for whole new classes of products that would never have been possible with conventional approaches. In medicine, the advent of MEMS chips for drug delivery can benefit any patient who must follow a regimen for medication, as a single chip embedded in a patient can release the correct amount of drug over a given period of time. Also, MEMS sensors embedded in scalpels allow surgeons to measure the force and depth of their delicate incisions. The industrial market will see MEMS chips that detect gas leaks and other pathogen agents, keeping the workplace safe. MEMS technology is everywhere. It has become an inevitable part of the path to more effective and diverse products at the consumer level and beyond, and has already improved our quality of life. Products with MEMS devices perform better, respond faster, and are more reliable. They improve current products in ways that are not possible with traditional electronics. The beauty of MEMS technology is that it is used in hundreds of products today, making it the technology of the present, but has the proven potential to be in millions more products in the future, thus securing its role as the technology of tomorrow. MEMS, realize the potential.
November 26, 2012, the Center for Nanoscience and Engineering at the IISc. As the day begins, 20 selected PhD scholars and young faculty members from across India gather to learn micro and nanofabrication fundamentals under INUP, or the Indian Nanoelectronics Users Program. The participants form 4 groups, each with a different device to fabricate. One of these devices is the cantilever. During orientation, participants are introduced to facilities at Census National Nanofabrication Center and the potential to conduct hands-on research. Then, a detailed explanation of clean room protocols to follow over the next 2 days is presented. NFC experts also present an overview of the fabrication and characterization processes the teams will deploy. After orientation, the teams proceed to the NNFC clean room. Here on, we will follow the cantilever route. At the outset, let's define the object our team will fabricate, namely a MEMS cantilever. A cantilever is a projecting structure, such as a beam, which is supported at one end only. It may carry a load at the free tip or along its length. Next, let's identify the broad microfabrication technology we shall employ, which is surface micromachining. This approach requires a silicon on insulator or soil wafer, which is a 3-layer material stack composed of the following. On top, a mechanically active device layer made of prime quality silicon. Intermediately, a buried sacrificial layer of silicon dioxide or box. This electrically insulating intermediate layer is selectively etched. at the bottom a support wafer or handle of bulk silicon. Our soy wafer has a 1 micron thick silicon dioxide layer buried under 200 nanometers of silicon layer. We initiate MEMS cantilever fabrication by cleaning the soy wafer. This is done in the wet etch bay. First, we place the samples in a wafer holder and dip it in the piranha bath of the wet bench. The samples are kept in the solution for 10 minutes. The piranha solution removes any organic and metallic contaminants from wafer surfaces. The solution is prepared by mixing sulfuric acid and hydrogen peroxide in a 9:1 ratio by volume. 10 minutes later, we remove the samples and rinse thoroughly with deionized water. This is followed by blow drying the samples with nitrogen. The samples are now clean and ready for the next step of photolithography. For the next step, we move to the lithography bay, which has a cleanliness level of class 100. Here, we shall transfer cantilever patterns from a glass mask onto the cleaned wafers. First, we dehydrate the samples at 250 degrees Celsius for 10 minutes to remove surface moisture. Next, we spin coat the wafer's device layer with photosensitive resist of nearly 1 micron thickness. Rapid spinning causes the liquid photoresist to spread uniformly on the wafer surface due to centrifugal forces. In this three-dimensional model, we see that the photoresist layer covers the entire device layer in even thickness. We now move the resist-coated samples for soft baking on an adjacent table. Soft baking is done at 95 degrees Celsius to evaporate the solvents in the photoresist. The soft-baked photoresist will not stick to the glass mask during the next step. In a similar way, we process the entire batch of wafers. We are now ready for cantilever pattern transfer, which takes place on a separate workstation. NNFC has an EVG double-sided mask aligner. First, we pick a cantilever mask prefabricated especially for INUP from our mask library. The mask consists of transparent and opaque parts that define a desired pattern. When we place this mask over the resist-coated sample and expose to UV light, cross-linked bonds in the resist are broken. We first load the samples onto the mask aligner tray. Then we place the mask on the wafer. Now the assembly is ready for ultraviolet exposure. UV light exposure is done at predefined energy levels specified in millijoules per centimeter square. After UV exposure, we must develop the pattern on the sample's photoresist. For this, a specified developing solution is taken in a petri dish. Next, we place the UV exposed samples in the developing solution. The photoresist now contains exposed and unexposed areas. The exposed part is soluble in the developing solution. Therefore, it dissolves, leaving behind a replica of the mask pattern. Once the pattern is developed, the sample is rinsed with DI water and given a nitrogen blow dry. We have now created the cantilever pattern on our sample's photoresist layer. To confirm, we make a quick microscopic inspection. The cantilever pattern shows up clearly on the microscope's display screen. The next stage of cantilever fabrication takes place in the dry etch bay. Here we employ the ICP RIE fluorine chemistry tool to etch the exposed device layer. These are our samples from photolithography. First, we apply formalin oil on a large carrier wafer to prepare a sticky base for the samples. Next, we place the samples on the carrier wafer. We now load the samples into the RIE station load lock chamber. Next, using the graphical user interface of the station, we create a vacuum in the load block. Then the samples are transported into the RIE main chamber. Gases start flowing inside the chamber at specified flow rates and temperature. Plasma strikes when appropriate conditions are reached. For our device layer of 200 nanometers, we have specified an etching time of 2 minutes. Let's understand in depth what happens inside the system. We are now watching the sample in an ions and plasma environment. Fluorine ions in plasma start etching the exposed silicon following a chemical reaction. After etching, we unload the samples from the RIE equipment. Since the bottom surface of the sample has formalin oil, we wipe it away with lint-free cloth. We now have the cantilever pattern on the device and photoresist layers. Again, we take a quick look through the microscope. Once more, we see clear images of the cantilever pattern. To remove the photoresist layer, we return to the wet etch bay. Here, we prepare a piranha solution of sulfuric acid and hydrogen peroxide in a ratio of 3:1 by volume in a glass Petri dish. The samples are then placed inside the solution. The liberated color confirms removal of the resist from the sample surface. This takes 10 minutes. Here, the piranha solution attacks the resist material, removing it from the wafer surface. Consequently, the samples now contain a patterned device layer over oxide. After photoresist removal, samples are rinsed with deionized water and blow-dried with nitrogen. Next, we come to the critical step of cantilever release using wet etch. Here, the buried silicon dioxide layer will be etched out with buffered hydrofluoric acid. The BHF solution has been previously prepared at the NNFC to etch at the desired rate. Since the anchor regions are much larger than the beam regions, Some oxide remains intact under the anchors after isotropic wet etch, creating a suspended cantilever anchored to the substrate. This is followed by a rinse with DI water and isopropyl alcohol. Here, care is taken to let samples remain in liquid. Otherwise, chances of stiction or cantilevers sticking to the substrate are high. To inspect the released cantilevers, we move to the lithography bay, which has the Leica microscope. The inspection must be carried out on submerged wafers from the previous step to avoid stiction. The release is confirmed by noticing that the cantilever and the substrate require differential focusing. Next, we advance to the step of drying the wafers in supercritical dryer equipment. First, we remove the top lid of the dryer to expose its inner chamber. Next, we fill the CPD chamber with isopropyl alcohol to immerse the special sample basket. At this stage, exposure of samples to air increases chances of stiction. So we transfer submerged samples along with IPA into the basket with a large spatula. Then we complete the basket assembly and lock the CPD chamber. Once samples are loaded, the equipment is turned on. Let's understand the ongoing process better. In supercritical dryer equipment, the IPA is replaced by liquid carbon dioxide. Once critical point conditions are created in the chamber, the distinction between liquid and gaseous phases is lost. As liquid carbon dioxide turns gaseous, the beams are released with minimal stress. As the drying process advances, LED displays indicate its various stages. During fill cycle, liquid carbon dioxide enters, and during heating, the critical condition is reached. After venting, samples are unloaded. We see that the chamber is completely dry, as are the samples. Unloaded samples are then taken to the characterization facility for final performance testing. We are now in the MNCF characterization facility adjacent to the NNFC. Here, we shall use a scanning laser Doppler vibrometer to verify that cantilever beams have indeed been released and therefore are functional. The laser vibrometer has a source of variable AC voltage that is applied across the sample's top and bottom silicon layers to create vibrations. The equipment has two probes to apply the voltage, a display screen, and specialized software to analyze vibration data. After placing the sample on the vibrometer, we position the probes to make contact with the cantilever's handle and the beam anchor in the device layer. Then we apply a specified voltage and observe the frequency response of the vibrating cantilever beams. The vibrometer picks up resonant frequencies of the fabricated cantilevers and displays corresponding velocity peaks. This confirms that our team has successfully created functional cantilevers. The vibrometer software also allows identification of vibration modes, such as first and second, by synthesizing a 3D animation from data taken along a user-defined path.
Thank you. So these are the videos I have shared you. I hope that you got information about fabrication and some MEMS applications. So I will share the funding agency PDF file. So a free time you can have. Coordinator, madam. Hello. Hello.
Hello, sir. Hello, sir.
Yes, madam. My side, my session is completed, madam. Next, you can start the test, madam.
Okay, sir.
Thank you, Srinivasa sir. You have shared great resources with all of us. Thank you very much.
Thank you, sir. Thank you so much.
See, the test questions I have mailed to everybody. Okay, the test questions have been mailed. Just send the soft copy, whatever answers you have done to the same mail, revert it back. I hope all of you have received the mail.
Yes, ma'am. Received.
Okay. Okay. I'll share it in the group too, those who haven't received.
Yes, received. Are we supposed to mail it back, madam?
Yes.
Okay. Yes, ma'am. Thank you.
Thank you.
Okay. The time within 9 o'clock, you please send me back.
Sure, ma'am.
Anupam, madam, can I leave the session, madam? Thank you, madam.
Sir?
Thank you.
Okay. Thank you, sir. Thank you so much.
However, people who don't have laptop, ma'am, because mobile, it is difficult to send it back.
All of you have logged in through mobile? How many are there?
So I myself have logged in through mobile.
Hello, ma'am.
Hello.
On ATAL web
No,
portal.
I have mailed it. Today I have mailed it. Tomorrow in the ATAL portal.
Please listen. On ATAL portal, there is a problem of logging because sessions are expired sometimes because of the interconnectivity. In some places, connectivity is not good. And there are 2 or 3 chances for login. After that, it will be automatically locked. At that time, how it is possible to give the test online? So better way is you can send the Google link or Google Forms. You can take the online test.
Maybe within 5 to 10 minutes difference, everybody will be able to log in, sir. I know initially it will be problem for everybody.
Yesterday I have tried a lot of times. For login, only 3 chances are there. If you are not logged, then that is automatically locked for that email.
Anupama, you can try both. You can send the link through WhatsApp group also, so that those who have problem in logging in with ATAL, they can take up the test through Google form. You can share the link through WhatsApp. Is there any?
Yes, ma'am. Google form option will be better, ma'am.
Even the mock shared the that would
have been. And the one you send now, then the question paper just now you sent now.
Yeah.
I can't answer because I logged in through mobile. Okay. So
you just try answering those questions.
We can just have a look into that, but I cannot send it back right now before the time what you have given. If you allow us to submit, we'll submit tomorrow because I don't have laptop.
One more thing you could have done, ma'am. You could have shared that through Google form. That would have been better.
No, today I didn't make the Google form. Tomorrow I'll just see what best can be done. I'll see whether through Google form or through ATAL website.
Won't carry laptops back home.
Madam, Madam, we have a humbly request to you, please go through the Google form.
Okay, sir. Okay.
Yeah, that
I
is the
just
better
told, right?
for participants
Yes,
who are
ma'am.
in the
Madam,
rural
a
area,
lot of
hilly area.
people have
it is very difficult for
people.
us.
Yes, ma'am.
So why does everybody have the difficulty in logging into the ATAL website? I didn't understand.
No, what they are telling is sometimes the network will be very poor. At that time, there may be some issues. Maybe because of that, they don't want to lose their certificate, right? So, for the benefit of participant, it is always better to share the link through WhatsApp or any, but through mail, whatever it is okay. So, maybe they feel comfortable.
Okay, I'll see what best can be done. I'll see. I'll take your inputs. I'll just go through. I'll just see.
Madam, can I get that when we can submit the test?
They do like
Hello, madam.
they share the link.
Hello.
Hello.
Now today's.
Can you share me, ma'am?
Hello. Today's within 9 o'clock.
9 o'clock.
Ma'am,
Yeah.
I'm not in a position to scan it.
Madam, it will be better if it is given in the form of Google form, and time should be little bit more because
How can we take the printout at this moment?
I am outside now. Please give some time realization for the submission.
Try as far as possible to send it. See, you need not take the print. Just send the answers.
No, for that when you take up from mobile, you have to take the answer. No, it will be difficult.
Yes, you send
How
only
to
the
write
answers and
answers then?
see options. Why can't you write the answers? I really don't know.
Madam,
Okay, we'll write
madam.
the answer and we should
Can
send
we
the answer
highlight them?
through mail.
Hello.
Madam?
Hello.
How
Can
we should
we highlight
send the
them?
answers?
Hello.
Anupama ma'am, can you hear me? Hello? Hello, ma'am? Hello, can someone tell me that how can we submit the all answers? Hello? Anyone is there?
Sir, ma'am is saying just write your answers in the Word file and mail again. Return back mail.
Okay, we'll have to return back the mail, huh? Okay. Got it, sir. Got it. Thank you,
Yes,
sir.
sir.
Madam said she will look into it.
ఏం కావాలి
పనిలో ఉన్నావా కాదనే అది
మీటింగ్
ఉల్లిపాయలు కోసి
Sir, we have to submit, sir. Very sure, sir.
Hello. If you can't
Yes, sir.
send the answers today, you can send it by tomorrow. No problem. Hello.
On mail, na, ma'am. On mail, na.
Yes. It is just a mock test. Fine.
Hello, sir. Hello, sir. Madam, please, 2 minutes. Hello, sir. Hello. Hello.
Hello, sir. Huh.
Sir, you take your own time, sir. Nothing to worry. Tomorrow by 2 o'clock, or please submit the answers by tomorrow. Tomorrow we'll create the Google Forms. This is only mock test because of your data is required. So sometimes ATAL-FDP will ask the proof for the test, the conduction of test.
Okay, sir. Okay.
Okay, take your own time, nothing to worry. So this is only mock test. Tomorrow we'll connect, we'll have Google Meet test only, nothing to worry. Tomorrow you take own time and you send me the back, whatever the answers, nothing to worry.
Okay, sir. Okay, thank you.
Okay, fine, thank you.
What's about today's final test, sir?
No, sir, it is a mock test only. Tomorrow through Google link only, we are going to conduct the test for 25 marks, sir. So we need
Okay, thank you.
your Yes, sir. We need your data. So we need to need your data for the record purpose, sir. So sometimes ATAL-FDP will ask the proof for the participants. So that's why we have made this
Thank you,
kind of
sir.
procedure.
Thank you. Thank you, sir.
Thank you. Thank you.
Okay.
Hello.
Yes, ma'am. Yes.
Sir, I'm very sorry, but I have received the test. I have received it on my mail ID also, but I don't know how to solve it, like how to fill the answers.